Hi, I'm Matt Diefendorfer. Welcome back to another tutorial. Today we're going to be talking about QSIprep. So QSIprep is a pre-processing pipeline for diffusion data. So this is very similar to fMRI prep, which we've done a video on in the past, that does pre-processing for functional images. QSIprep does pre-processing for diffusion images before you start doing analysis like predictive tractography or NODI or anything like that. So it takes your raw data out of a BIDS format and performs standard pre-processing steps in order for you to get to a state where you can run your actual analysis. So QSIprep documentation can be found at qsiprep.readthedocs.io. I have to say this documentation is very good overall. It goes in quite in depth into all of their processes and all of their outputs and everything like that. So I would definitely come to their documentation and read through it. You'll learn a lot about exactly what they're doing. So moving into it, we can talk about exactly what their pipeline is. So if we take a look at their pipeline, they have a number of steps that are again, pretty well agreed upon as far as necessary steps to get raw diffusion data into a state where they're actually usable for analysis. So first, you're going to have your diffusion data as well as field maps. So these field maps can be either magnitude and phase encoding field maps, or they can be spin echo field maps, or they can be whatever sort of field maps that BIDS supports. Doesn't really matter. But they are going to first group your diffusion data by essentially by direction and session. And then they'll perform denoising. They're going to concatenate all of the diffusion scans by default, perform denoising on the diffusion scans, then distortion correction. You can choose from a couple different algorithms for doing distortion correction. They have top up, which is your basic FSL distortion correction, as well as gradient recall echo, field mapless, whatever you want to choose. You have, and then they also perform head motion correction using either FSL's eddy current correction pipeline, or their novel shoreline method. You can choose either one. It can perform head motion correction and all of these corrections on a variety of sample schemes, so DSI, DTI, multi-shell, whatever you have, it can handle. If you have multiple sessions, it can also build a subject B0 template. So it takes all of the reference B0 images from each of the diffusion scans and creates an average that helps for correction to the template. So as opposed to trying to correct from one scan to another scan's B0 template, it will create just an average template that it'll correct all of the diffusion scans to. And then it performs registration and normalization, so it takes all of your diffusion data, it then co-registers it to T1 native space first, and then if you so choose, it will register it to a template space, so to standard M&I space, whatever you want. It'll register to it. It does go through T1 space first, though. From there, that's the pre-processing stream. You can stop at the end of the pre-processing stream, which is what we're going to do in this tutorial, but they also have some reconstruction options available to you to choose from. It has a variety of tools packaged into the container that you can choose from and apply. But we're not going to go over any of the reconstruction in this video. That's more going to be for the researchers themselves to determine exactly what you want to do as far as analyzing your diffusion data. So just the pre-processing steps over here are going to be performed in this tutorial. So that's really the entire pipeline. It's very simple overall. concatenates the diffusion scans if you so want, denoises them, distortion corrects with field maps, performs head motion correction, and then does registration and normalization. So that's how QSIprep works in theory, but how do you use it on Qsi? So luckily, if you go to our documentation, uab-cinl.github.io, we do have a section on using QSIprep in our MRI preprocessing and analysis. QSIprep is very simple to use overall, just to be honest. Installation works very similar to fMRI prep or to a couple of the other things that we've looked at, such as MRI QC, where it's available in a singularity container. So installation onto Qsi, you just load up the singularity module, and then you pull the QSIprep image from their Docker hub. This is from University of Pennsylvania. So you pull the image file from their Docker hub and convert it to a singularity image file, and you can just use that however many times you want. Right now, the version that I would suggest using is 0.14.3. That's the most recent stable version that I've found that works on Qsi. They just put out a new version 0.16.0.3 kind of that I have not tested on Qsi that should fix some of the issues from 0.15, but right now suggested version is going to be 0.14.3. You can try out the new 0.16 if you would like, but I have not tested it yet. But you can pull that down into an image file and just use it whenever you need to. The usage is also very similar. So I mentioned previously that this is a BIDS app. So you convert all of your raw data to BIDS format first. And then it looks and behaves very similarly to fMRI prep. So you have Singularity run, you give it the path to the Singularity image file for the QSI image file that you downloaded earlier. There are some optional arguments that I have listed out that we can talk about here in a second, but then you have the three required positional arguments in order to run at least the base version of QSIprep. So you have the BIDS directory. So this contains the actual subject name BIDS sorted directories in it. You have the output directory. In our case, I've always put the output directory as a derivatives directory within the BIDS directory. And then the analysis level. Currently, the only available option for the analysis level is participant, so just put participant each time you run it. Additional arguments that you can put in. So -- participant label, I would suggest always using this one and just running a single participant. If you have multiple participants you want to run, then we can talk about how to run multiple participants later. We'll do that via an array job as opposed to listing multiple participants in a single job. So I would always use the participant label option, and then you just put a single participant name that you would like to run through. You can omit the -- tag from the label. You can run it with or without. It doesn't really matter. Another additional argument that I find useful in some circumstances is the separate all DWIs. So like I said when going through the pipeline, the default behavior for QSIprep is to concatenate all of the DWI runs together from a single session and then perform preprocessing. So that's really useful if you have multiple diffusion directions that are scattered between different diffusion runs. So like for the HCP pipelines, they had 98 diffusion directions in one scan, and then 99 different diffusion directions in another DWI scan. So default behavior would be for QSIprep is to concatenate the 98 direction scans with the 99 direction scans, and that way you have a set of 197 diffusion directions that you would be analyzing across. The separate all DWIs argument will instead keep those 98 and 99 direction scans separate. and all pre-processing is done on each individual scan instead. It's really up to the researcher as to how they want to do it, but that option is there for you to use. You also have the output resolution. So output resolution is actually a required argument, but it's not positional. You set it via the output resolution tag. This is going to be the isotropic voxel size that all of your output DWIs are going to be resampled to. You can keep it as the native resolution, or you can resample it to whatever you want. You just have to be sure to set that. Additionally, QSIprep does use FreeSurfer for some steps. It's not going to perform the recon all by default, but it's going to use it for some steps. So, like with fMRI prep, you are going to need the FreeSurfer license file, and you just need to give it the path to the FreeSurfer license file. We have instructions on the fMRI prep docs for how to use that. This is a required argument again. And then you also have the working directory. So this is just a path to a working directory to store intermediate results. These files will be deleted after the script ends. You can set it to be whatever you want, or you can set it to be nothing, and then the working directory will just be put where the script is run from. But that's up to you. This is not an exhaustive list of optional arguments. You can, again, find the exhaustive list in their documentation. And you can see that there is a large number of arguments that you can pick from to really customize how your diffusion pre-processing performs. So if you're looking for something that I didn't talk about, definitely look through this documentation here to try and see if QSIprep can do exactly what you want it to do. And like I said, the documentation, the options are all very well explained. So just look through and find what you need and play around with it. Another thing to mention here are the field maps. So when you're using field maps for distortion correction, you're going to need to include the intended for field in the field map JSON sidecars that name the diffusion scans they're intended to correct. So for instance, if we go to some test data that we've got over here for subject 01, we go to their field map and open up one of their JSON files for this is an AP direction Spinnaker field map. Normally, all of this metadata is in here by default, except for this intended for field. This is not put in by default. You're going to need to do it manually. And what the intended for field does is it associates specific field map files with the scans that they are intended to perform distortion correction on. So in this case, I only have 2 field map files, and I want to apply these 2 field map files to all 3 of my EPI sequences. So EPI sequences are going to be your bold scans and your DWI scans. So in my case, I want to apply the distortion correction using these field map files here to my AP direction DWI scan, as well as both of my resting state scans. And you're going to need to do that for both, in my case, we've got 2 field maps, one in the AP direction and the other in the PA direction. You're going to need to put the intended for field in both of them. And the intended for field should be the same for both of them, okay? So be sure to have that. If you don't have that, it's not going to perform field map distortion correction, obviously. It may choose to perform a mapless distortion correction. But if you're wanting to use your field maps for distortion correction, you're going to need to have this intended for field in there. So that's it as far as setting up the command. It's, like I said before, it's a very simple command. You don't need to do too much with it. Outputs. Luckily, the documentation for QSIprep has a very detailed list of QSIprep outputs. So you can go over there, and it has outputs of QSIprep. And then you're going to look for the pre-processed data listing here, and it's going to go through all of the all of the output files that it creates tell you exactly what they are. It's really, really nice. So we'll take a look at that whenever we go over the example. So we're not going to spend too much time here. But we have a couple of example scripts at the bottom. So the example scripts are very simple, and they look very similar to what the fMRI prep scripts do. So you've got the SBatch options at the top. So these are all written to be used on the Qi cluster. You can use them if you're going to use them on a different cluster, then you're going to have to change the options based on the scheduling. But if it runs Slurm, then you can run it anywhere. So you've got your SBatch options. In my experience, running it with just a single DWI scan, it'll run in a few hours. You can use it with multiple CPUs. I've also run it on the AMD-HDR 100 partition. It's run perfectly fine. This partition is not used very often, so you can schedule jobs very easily here and get them running pretty quickly. Time, I would just suggest 50 hours for it for a number of DWI scans. So if you have 4, 5, 6, or whatever, I would just suggest 50 hours starting out, and then based on how long it runs, you can adjust your time up or down based on what you need. And then I've set it to be 10 gigs per CPU, 10 gigs of memory per CPU, so 40 gigs total. I did run out of memory when I tried to do it with like 20 gigs, so I would suggest starting out with 40 gigs and then seeing what you need. If the job doesn't finish because it runs out of memory, then adjust up. If the job does finish, then you can look at the efficiency of the job and see if you can adjust the memory down. But 40 gigs worked for me, so that is a good starting point. As far as setting up the script to run, this example script here is just for a single subject. You set the bids directory, you set the participant label, you load up the Singularity module, and then CD to the directory that has the QSIprep Singularity image in it. And then you just run Singularity run, give it the name of the QSIprep image file, give it the participant label, which is set from here, the path to the free software license file. -V means the verbose option. In my case, I've got separate all DWIs in here because that's what I was using for an analysis earlier on. But again, you can keep that out if you'd like. And since I'm only running one DWI image here, it doesn't really make a difference. The output resolution I've set to be 1.2. That's the native resolution for my images. And then I told it to skip bids validation as well. And then I've given it the bids directory as the first positional input, the derivatives folder as the output directory, and then the participant level. So that'll run a basic version of QSIprep from beginning to end for one participant. If you're wanting to run on multiple participants, as opposed to setting multiple participant labels in here, which will make them run serially, which will make it run over many, many, many hours, instead, you should run it as an array job. So this is going to look really similar to our array job for fMRI prep. If you want to go back over to those examples, we're going to take advantage of the participants.tsv file that gets output whenever you convert data to a bids format, and read the participants' names from this participants.tsv file. The array script will, based on the array index that we give whenever we submit the script, it will pick out the subjects that you want to run and replicate this script multiple times based on the number of subjects, and create one job for each participant. Otherwise, everything's pretty much the same as far as the running of QSIprep goes. It's the only thing that's really changed is this participant here just reads from the participants.tsv file. And then whenever you submit the script, you're going to need to give an array index starting from 0, which would be the first participant, up to the max participant number -1, since these are 0-based indexes. You can feel free to go to fMRI Prep Examples to see a little bit more information about how to run that, or you can go to the Research Computing Documentation and search for array jobs to see how to run array jobs. So that's the script. Again, very simple, very straightforward. So let's take a look at the output. So I've run QSIprep, and I've got, it puts it in the derivatives folder here, just a QSIprep folder. I've run it on 2 subjects. We'll just take a look at one of them. The outputs of QSIprep are going to be divided into an anatomical folder, a diffusion weighted folder, and then a figures folder. Ideally, QSIprep would create visual reports on how well detailing how well it performed. Using version 0.14.3, I have not gotten the visual reports to work correctly. Instead, the output report will give you copy and paste pre-processing, a pre-processing template for you to copy and paste into your papers or your reports whenever you are presenting your data. That way you don't have to write up the pre-processing steps on your own. But I've not gotten it to actually generate visual reports. So that is one thing that hopefully will be fixed in version 16. But if we go into our subject here and go into the anatomical folder, the steps that it performed are really just, it does some slight pre-processing to the T1 volume image, creates a brain mask from it, and then creates native space, CSF, gray matter, and white matter probability maps. So you can use these as masks for, you can convert these to actual masks. Say if you're doing NODI and you only want to apply your analysis to the white matter or to the gray matter, or you can use it as the brain mask as well. That's fine. Or you can use these with FSL, I believe, as well. And then these same files, so the T1 image, the CSF, gray matter, and white matter probability maps are also transformed into M&I space as well. So you have your native space images and then your M&I space images, and they're just the same thing, just in different spaces. So that's it as far as the anatomical outputs. The DWI outputs are also not incredibly complicated. You have your confounds in a TSV file. If you want to try and regress out any of the confounds, they've got those listed in the TSV file here. So frame-wise displacement, which is a motion parameters based on how much the subject has moved from the first frame. And then you can read through, you have the B value, which is going to be the field strength. You've got a large number of confounds that you can look through, and if you want to try and regress them out or use them in your analysis, then that's perfectly fine. Those are just located in the TSV file there. You've also got the brain mask in T1 weighted space, so this is going to be the same thing as the brain mask in the anatomical. You also have the BVAL and BVEX files. So the BVAL and BVEX files are going to be used with FSL for actual analysis. And then you have a .b file, which can be used with MRTRIX3 for analysis. So .b goes with MRTRIX, BVAL, BVEC go with FSL. And then you have the the actual pre-processed Nifty file. So this is going to be the output file that you're going to use either in further pre-processing, or you can use in just put it straight into an analysis script. Other than that, that's really all there is to it. If you have multiple DWI images, then all of these files are going to be replicated based on the number of DWI images that you've got. But really, that's about it. If you have any questions, feel free to shoot me an email at mdefendi@uab.edu. You can also feel free to come to Research Computing office hours. So if you go to uabrc.github.io and go to the Contact Us section right here, we have office hours from 10 a.m. to 12 p.m. on Mondays and Thursdays every week, besides when there are holidays. And these are held virtually on Zoom, so you can just click the Zoom links here and join, and feel free to ask about any questions that you might have. So yeah, if you all have any questions, feel free to stop by, shoot me an email, whatever. I hope this has been useful, and have a great day.